Hello everyone. In today's session, we will practice problems of projection of lines by using given information regarding the line. So before starting the practice of problems, let us take a look on meanings of different terms shown in the diagram of projection of lines. So here I have taken a master problem of projection of line, in which I have shown different terms like TL, theta, alpha, Fe, that is EL, TV, that is plan, or PL, beta, phi. So what are the meanings of these different terms? So TL means true length of the line, and it is shown by AB1 and A dash B1 dash in the diagram. So TL is the true length of the line and it is shown by A dash B1 dash and AB1 in the diagram. Then after FE or EL, so that is front view or elevation of the line. Front view or elevation, so it is shown by A dash B dash in the diagram. So A dash B dash will have a elevation or front view of the line. Then after top view or plan of the line, that is TV or PL. So top view is shown by line AB in the diagram. Then after EP, that are the end projectors of the line, or a perpendicular distance between projectors of end of the line. So we can see that here this is the projector of A and this is the projector of B, and the perpendicular distance between these two projectors is considered as the end projectors of the line. And we can also see that on projector of A we have shown elevation of A and plan of A, and on projector of B we have shown elevation of B and plan of B. Then after theta, theta is the angle of inclination of the true length of the line with the horizontal plane, and theta is shown by a line A dash B1 dash, that is our true length. Then after phi, phi is the angle of inclination of the line with the vertical plane, or angle of inclination of the true length of the line with the vertical plane. So phi is the angle shown by a line AB1. So AB1 is our true length. So we can say that this theta and phi are the true angle of inclination of the line also. True angle of inclination of the lines. Then after alpha, alpha is the apparent angle made by front view of the line with the XY line. So alpha is the apparent angle made by front view of the line with the XY, and we can also say that it is the angle of line A dash B1 dash, because A dash B1 dash is our elevation or front view. Then after beta, beta is the apparent angle made by top view of the line with XY. So beta is the apparent angle made by the top view of the line with XY line, and we can see that it is the angle of AB, and AB is our plan. Now another thing is how to derive this elevation and plan of the points, and you can also see that B dash and B1 dash are on the same locus, that is locus of B dash and B1 dash. Here B and B1 are also on the same locus, that is the locus of B and B1. So now how to derive a plan and elevation of the line. So to understand this, let us take a look or quick overview on projection of points. Projection means to draw the top view and front view of the point. So how to indicate the plan and elevation or side view of the point? So to indicate the plan of the point, we will use small ABCD up to Z. To indicate the elevation of the point, we will use small ABCD with dash on it, that is A dash, B dash, C dash, D dash, M dash, N dash, whatever it is. And to indicate the side view of the point, we will use A double dash, B double dash, C double dash, d double dash or e double dash up to z double dash. Now position of the point with reference to HP and VP. So first position is point is in first quadrant. So if the point is in first quadrant, it is above HP, in front of VP. Second quadrant. So if the point is in second quadrant, we can say that a point is above HP, behind of VP. Third quadrant. So if the point is in third quadrant, we can say that a point is below HP and behind of VP. Fourth quadrant. So in the fourth quadrant, we can say that a point is below HP, in front of VP. Then after, on HP, in front of VP. That means the point is on horizontal plane and in front of the vertical plane. Then after, on HP and behind of VP. That means a point is on horizontal plane and it is behind of the vertical plane. Then after, on VP, above HP, on VP, below the horizontal plane, and on HP, on VP. So we have these 9 different position of the point with reference to HP and VP. So if we have these positions, how can we derive the plan and elevation of the point? So let us see the conclusion of projection of points. First is, if the point is above HP, then the elevation of the point will above the XY reference line. So we can say that if the point is 10 mm above HP, the elevation of the point will be 10 mm above the XY reference line. If the point is below HP, the elevation of the point will be below the XY reference line. So we can say that if the point is 15 mm below HP, the elevation of the point will be 15 mm below the XY reference line. If the point is in front of VP, the plan of the point will be below the XY reference line. So we can say that if the point is 30 mm in front of VP, the plan of that point will be 30 mm below the XY reference line. Now if the point is behind of VP, the plan of the point will be above the XY reference line. So if the point is 40 mm behind of VP, the plan of that point will be 40 mm above the XY reference line. Now if the point is on VP, if the point is on VP or in the vertical plane, then the plan of the point will be on the XY reference line. And if the point is on horizontal plane, the elevation of the point will be on XY reference line. And we can also say that if the point is on HP and on VP, then the plan and elevation will be on the XY reference line. And here we have also shown that if you want to indicate plan, we have to use small ABCD. If you want to show elevation, we have to use A dash, B dash, C dash, D dash. And if you want to show the side view of the line, side view of the point, we have to indicate A double dash, B double dash, C double dash, D double dash. So if you want to learn the projection of point in detail, then watch my video on projection of point, and the link of the video is given in the description. So let us start the practice of problems. So in today's session, we will have the problems in which the information related the true length of the line is given. Information related to true length is given. So this is our question in which the information related to true length is given, that is theta and phi, and we can say that theta and phi are the angle of inclination of the true length of the line. So that is the information related to true length. So let us start this problem. A line AB 80 mm long is inclined to horizontal plane by 30 degree and inclined to vertical plane by 45 degree. The line is in the first quadrant. The line is in the first quadrant with point A 15 mm above HP and 30 mm in front of VP. Draw the projection of the line AB. So we have to draw the projection of the line. That means we have to draw the plan and elevation of the point. So let us recall the given data. A line 80 mm long, that is TL, that is true length of the line, is 80 mm, is inclined to horizontal plane by 30 degree, and the inclination of the horizontal plane is theta, so theta is 30 degree, and inclined to vertical plane by 45 degree, so phi is the angle of the line with the vertical plane, and it is 45 degree. Here we can see that the line is in the first quadrant. First quadrant means the line is above HP and in front of VP. So the line is in the first quadrant with point A 15 mm above HP and 30 mm in front of VP. So the point A is 15 mm above HP and 30 mm in front of VP. Draw the projection. So let us start. So first of all, draw XY reference line. Now mark the point A. That is, mark the elevation and plan of point A. So A is 15 mm above HP and 30 mm in front of VP. So we can say that the elevation of the point A will be 15 mm above the XY reference line, and plan of the point A will be 30 mm below the XY reference line. So mark the points A dash A. So A dash is the elevation 15 mm above the XY line, and A is the plan 30 mm below the XY reference line. Now draw the locus of A dash and locus of A, which should be parallel to the XY reference line. So this will be locus of A dash and this will be locus of A. So after deriving the locus, first of all we have to apply this data. That means we have to draw this true length with theta and phi. So we can see that we can draw true length with theta angle from A dash. Okay. Now the point B is also in the first quadrant, so we will get the B dash, that is elevation of point B above the XY reference line, and plan of the point B below the XY reference line. So from the A dash at an angle theta 30 degree, draw the true length of the line, which is 80 mm. This point is A dash and this point will be B1 dash, which is our true length. And from point A in the downward direction, because the point B is in the first quadrant, we will get the plan of the point B below the XY reference line. So from point A, draw a line incline and angle of 45 degree, that is our phi, angle of inclination with the vertical plane with true length. This point will be B1 point. Now draw the locus of B1 dash, that will be also the locus of B dash, and draw the locus of B, that will be the locus of B1 also. Now we have to draw the projection of the line. That means we have to draw the front view and top view of the line. And if we have true length, how can we derive the front view and top view of the line? So for that, draw a straight line from B1 dash up to locus of A. Draw a vertical line, that is a straight line. It should be perpendicular to the XY reference line from B1 dash up to locus of A. The intersection of this line and locus of A will be a point B2. Now measure A to B2, and give an arc on the locus of B from A. So from A, measure A to B2 and give an arc on the locus of B. The intersection of this arc and locus of B will gives us the plan of point B. So connect B to A. This will be our plan length, and the angle of the plan length will be beta. Now if you want to find the elevation length, draw a straight line from B1 to locus of A dash. The intersection of this line to locus of A dash is a B2 dash. Now measure A dash to B2 dash, which will be our elevation length, and give an arc up to locus of B dash. Now join, so this point will be B dash. Now join B dash to A dash will be our elevation length, and the angle of the elevation length is alpha. So this will be our elevation length, and this will be our plan length. Now we can see that say that B dash and B will be on the same vertical line. That will be the projector of point P, and the perpendicular distance between the end projectors of line is considered as the EP. So this will be our final projections. Now let us draw some one another problem in which we are going to change the quadrant of point B. Right now the point B is in the first quadrant. That means we can say that it is above HP, in front of VP. In next problem we will change the quadrant of point B. So a line AB 80 mm long is inclined to horizontal plane by 45 degree and inclined to vertical plane by 30 degree. The end A is 20 mm above HP and 15 mm in front of VP. Draw the projection of the line and also write elevation length and plan length of the line. Now here we have to write we have to measure the elevation length and plan length also. So let us recall the given data. Line AB 80 mm long, that means the true length of the line is 80 mm, is inclined to HP by 45 degree, that means theta is 45 degree, inclined to vertical plane by 30 degree, that means phi is 30 degree. The end A is 20 mm above HP and 15 mm in front of VP. So it is above HP, in front of VP. So we can say that the point A is in the first quadrant. It is 20 mm above HP, 15 mm in front of VP. And in the answer we have to write down the length of the elevation and length of the plan. So elevation length and plan length. So after deriving the projection we will measure elevation length and plan length and we will write down the answer over here. So first of all, here we can see that the quadrant of point B is not given, and in the first problem we have taken the quadrant of point B, or we have taken point B in the first quadrant. So in this question we will change the quadrant of point B. So let us assume the quadrant of point B. So assume point B in the third quadrant. That means we can say that point B is below HP, behind VP. So if the point is below HP, behind VP, we will get the elevation of point B below the XY reference line and plan of point B above the XY reference line. So you have to take this in mind and you can start the drawing. So let us start. First of all, draw XY reference line. Now mark point A, which is 20 mm above HP. Above means the elevation of point A will be 20 mm above the XY reference line, and it is 15 mm in front of VP. So we will get the plan of point A 15 mm below the XY reference line. So first of all, mark A dash A. So A dash is 20 mm above XY reference line and plan of point A is 15 mm below the XY reference line. Draw the locus of point A dash and A. So this will be locus of A dash, this will be locus of A. Now next thing is we have to derive the true length from A dash with theta angle. From A we have to derive the true length, or we have to draw the true length at an angle phi. But here we have changed the quadrant of point B. So we will right now we will get the elevation of point B below the XY reference line and plan of point B above the XY reference line. So from the A dash we have to draw the true length at an angle theta in the downward direction, because we will get B dash below the XY reference line because it is in third quadrant. This point will be B1 dash, and from A we have to draw the true length at angle phi, which is 30 degree in the upward direction, because the plan of the point B will be above the XY reference line. So this will be B1. Now draw the locus of B1 and B1 and B. This locus is also considered as the locus of B. Locus of B dash and B1 dash. So we will get the B dash on this locus. Now we have true length, and if we want to draw the projection, that means if we want to find out the plan and elevation of the line, we have to draw a straight line from B1 to locus of A dash, and the intersection of this projector and locus of A dash is the point B2 dash. Now measure A dash B2 dash. Measure A dash B2 dash. We can say that A dash, the distance between A dash and B dash will give us the elevation length. So now measure A dash to B dash and give an arc on locus of B dash. So here we will get elevation of point B, so that is B dash. Joint B dash to A dash will be our elevation length, and the angle of the elevation length will be alpha angle. Now if you want to find the plan, so if you want to draw the plan, draw a straight line from B1 dash to locus of A. B1 dash to locus of A. We will get the intersection at B2. Now measure A to B2. We can say that AB2 is our plan length. But we have to find out the plan of point P, and it will be on locus of B. So we have to rotate AB2 up to locus of B. So for that we have to measure A to B2 and we have to give an arc on locus of B. So measure A to B2 and give an arc on locus of B. Here we will get plan of point B. So this point is the plan of point B. Join point B to A. We will get the plan of the line, and the angle of the plan is beta angle. At the end we have to check that we will get the projector on the same vertical line, B dash and B. Now we have to measure the elevation length and plan length. So measure elevation length and plan length. So elevation length will be equal to 69.28 mm and plan length will be equal to 56.56 mm. Now let us practice one another problem by changing the data, not the quadrant, but by changing the data or by changing the given data. A line AB 75 mm long has its end A 20 mm below HP and 25 mm behind VP. Then B is 50 mm below HP and 65 mm behind VP. Draw projection of line AB and find its inclination with HP and VP. So let us recall the given data. A line AB 75 mm long, that means we can say that the true length of the line is 75 mm, has its end A 20 mm below HP and 25 mm behind VP. So point A is 20 mm below HP and 25 mm behind VP, and the end B is 50 mm below HP and 65 mm behind VP. So the end B is 50 mm below HP, 65 mm behind VP. Draw the projection of the line AB, that means we have to draw the plan and elevation of the line and find the inclination of the line with horizontal plane and vertical plane. That means we have to find the theta and phi. So theta is the angle of inclination of the line with the horizontal plane, and phi is the angle of inclination of the line with the vertical plane. Now here we have changed some data. So in place of theta and phi we have given the locus of point B. So let us start. So first of all, draw XY reference line. Now mark point A. So A is 20 mm below HP and 25 mm behind VP. So the elevation of point A will be 20 mm below the XY reference line, and plan will be 25 mm above the XY reference line. So mark A and A dash. So plan of point A will be 25 mm above XY reference line and elevation will be 20 mm below the XY reference line. So mark point A and A dash and draw locus of A and locus of A dash. So this is locus of A and this will be locus of A dash. Now here we doesn't have theta and phi. So now we have to change our method. So now draw the locus of B. Right now we cannot mark B dash and B directly because we doesn't have the length of the end projectors. So right now we will draw the locus only. So B is 50 mm below HP. So the elevation of point B will be 50 mm below the XY reference line and it is 65 mm behind VP. So the plan of point B will be 65 mm above the XY reference line. So below 50 mm of xy reference line, draw locus of b dash and b1 dash, because we will get the elevation of point B 50 mm below the xy reference line, and measure 65 mm from xy reference line and draw locus of B and B1, because B is 65 mm behind VP. So we will get the plan of point B on this locus. But right now we doesn't mark B dash and B directly on this locus because we doesn't have the distance of end projectors. So now we have only the true length. So measure this true length, that is 75 mm on the rounder, and put your rounder on A and give an arc on locus of B. So that point will be our B1 point. And again measure 75 mm true length and give an arc from A dash also on locus of B dash. We will get B1 dash. So B1 is our true length, and the angle of this true length AB1 is phi. That is the angle of inclination of the line with the vertical plane. And joint A dash B1 dash will also a true length but at an angle theta. Now same process to find the plan and elevation of the line. So if you want to draw the plan of the line, draw the straight line from B1 dash up to locus of A. This point will be our B2. Measure A to B2 and give an arc on locus of B. So this point will be our plan of point B. Join B to A will be our plan length at an angle alpha. Now if you want to draw the elevation, draw a straight line from B1 to locus of A dash. The intersection will be B2 dash. We can say that A dash B dash is our elevation length, but it is not our elevation. So if you want to find out the elevation of point B, we have to rotate this B2 up to locus of B dash. So measure A dash B2 dash and give an arc on locus of B dash. So here we will get elevation of point B dash. Now connect B dash to A dash will be our elevation length at an angle beta. So angle of the elevation length is beta. Draw the end projectors to check the correct projectors. And now measure theta and phi. So if we measure theta, theta will be equal to 23 degree and phi will be equal to 31 degree, that we have to find. So this is it for today. We will practice some more problems in the next session. Thank you.